So the last example I've got for you is, I've just called it optical isomers, but you are asked for an optical isomer for your last question 10 of the worksheet. So just a reminder, in the middle here we have a carbon. This carbon is a really special kind of carbon. It's called a chiral carbon atom. What that means is it has 4 different things at the end of its bond. It's got one CH3 group, it's got a nitrogen, an alkyl group, a chlorine. These are 4 different things. Whenever we have 4 different things around a carbon, it is one of these special chiral carbon atoms that can undergo this optical isomerism. What we said in class was that we can have almost a left and right-handed version of it. Your hands are chiral because you have 5 things attached to them, 5 fingers, but each finger is a little bit different to all the others. And if you look at your 2 hands, you can put them in like a praying position, and you can kind of overlay one to the other, and that means they're mirror images of one another. But if you put one in front of the other and try to rotate it to overlay, it can't. So your 2 hands are actually different. You have a left hand and a right hand. They're mirror images, but they're not actually the same hand. You'd look a bit weird if you had 2 right hands or 2 left hands. So what we're going to have a look at is how we would represent the other version of this. As before, we just need to swap the positions of 2 of these, and it could be any 2. Doesn't matter which. If we swap the position of 2 of them, that is the special trick that means we can find the other optical isomer. I'm just going to go with the nitrogen and the oxygen group. So if I make this one the nitrogen, I'll just turn that off for now. And if I make that one the oxygen group, what we have is we have the optical pair. Oh, that's what happens when you don't select it properly. What we have is the optical pair. If I tried to overlay them, I can get the chlorine and the CH3 to match up, but the N and the O will never match up. And any way I rotate them in 3D space, that will be the case. They are different molecules. So that would be your last example.